Simplifying rational expressions. What are rational expressions? A rational expression is an expression in the form px over qx, where px and qx are polynomials. Here are 3 examples. The domain. The domain is the x value that can be used in an equation. Rational expressions are fractions. They cannot have 0 in the denominator. Finding the domain. Set the denominator equal to 0. Solve either linearly or quadratic. Write domain restricting the number above from it. Okay, the domain. So we're going to set the denominator equal to 0. So x plus 4 equals 0. So x equals negative 4. So our domain is all real numbers except for x cannot equal negative 4. So what are the values of x is expressed as undefined? So we have to set our denominator equal to 0. So this is a perfect square binomial. So this is where we have 2 perfect squares and it's being subtracted. So you're going to square root the first term and square root the last term. One's going to be positive and one's going to be negative. So our x equals negative 2 and x equals 2. So our domain is all real numbers except for x cannot equal negative 2 and 2. Because if we were to put either of those in there, this would end up equaling 0, and that is undefined. Okay, find the domain, x minus 2 over 3x. So we need to set 3x equal to 0. So x equals 0. So our domain is all real numbers except for x cannot equal 0. For what value of x is the expression undefined? So we're going to set our denominator equal to 0. So I need to find 2 numbers that multiply together that equal 6, but add together to equal 5. So 2 and 3. And set each one of those equal to 0. So x equals negative 2 and x equals 3. So my domain is all real numbers except for x cannot equal negative 2 and cannot equal negative 3. So negative 2 and negative 3 are the values for x that would make this expression undefined. Simplifying rational expressions. Factor numerator and denominator. Reduce and cancel pieces of monomials. Cancel any like binomials, trinomials, etc. All or nothing with binomials and trinomials, etc. Okay, so let's reduce here. So I can reduce 3 and 6 by dividing by 3. So then that would become x, that would become 1 over 2. And then x, remember when we're dividing exponents, we subtract. So 2 minus 1, 1. So 1x over 2y. So that will become x over 2y. Okay, so this is a binomial. I cannot cross off a monomial and a binomial. Remember, it's all or nothing. So I have to factor out my 2. Now I can cancel out the 2's and get x over x plus 5, which is my answer. Okay, so 3x, or x to the third minus 6x over 2x. Okay, so this is a binomial, so we can't just cross off the 2 and 3, so I have to factor out an x. So once I factor out an x, now I can subtract. So this would be x1 minus 2, which would be negative 1, which then that would bring it back to the bottom. So then I'd have x squared minus 6 over x. Okay, So here, I can factor out a 2x. Okay, so that becomes x minus 3. And then on the bottom, this is a perfect square binomial. So then that becomes x plus 3 and x minus 3. And then now the x minus 3 cancel out, leaving me with 2x over x plus 3. Okay, simplify. X squared plus 6x plus 9 all over x minus, or 9 minus x squared. Okay, so I can factor. I need to find two numbers that multiply together to equal 9 but add together to equal 6. So 3 and 3. And then this is at negative x squared plus 9, so I want to write this in standard form. I'm going to factor out the negative sign. So then this becomes x plus 3 and x minus 3. Then the x plus 3's cancel out, leaving me with x plus 3, or negative x plus 3 over x minus 3. Okay, we'll do the same over here. So I'm going to rearrange, and then I'm going to factor the bottom. Then I'm going to factor out a negative. Then this becomes a perfect square binomial, so then it becomes x plus 2 and x minus 2. My x minus 2 cancel out, leaving me with x plus 2 over x plus 1, all negative. Your turn. So try these ones on your own and see if you get the same answer.